So very good morning to all person here. Myself Anand. I'm working as assistant professor in the Department of Mechatronics Engineering in past 9 years. This is a lecture video series. In this is the third video. We are discuss about basic concept of electrical electronics engineering. In previous two sessions. In previous two sessions, we discussed about Ohm's law and then the definition of current and voltage, resistance, the relationship between voltage, current and resistance. So now we are going to discuss about the concept of Kirchhoff law. This is a topic outline. One is Kirchhoff law, KCL, KVL, and then problems. What is meant by KCL? KCL is nothing but Kirchhoff current law, and then KVL is nothing but Kirchhoff voltage law. So before going to the topic, we see the Ohm's law recap. V equal to IR. What is Ohm's law? Ohm's law is nothing but in a current carrying conductor, the potential difference between 2 points is always proportional to the current flow, electron flow in a circuit. So it is expressed by V, that is voltage, always proportional, that is proportional to current carrying in the same conductor. V directly proportional to the I. And also we can express the equations like V equal to IR, I equal to V by R equal to V by I. This is the basic relationship between V, I, R. And then coming to the Kirchhoff current law, the sum of, this is the first law, the Kirchhoff stated two laws, that is Kirchhoff current law and Kirchhoff voltage law. This is the first law, Kirchhoff current law, KCL. The sum of current entering a node or junction point is equal to sum of current leaving, or incoming current is always equal to outgoing current. For example, this is the circuit shows that we have four types of current directions, that is IA, IB, IC, and then ID. So in the center point, IA, then IB are incoming current. Likewise, IC and ID are outgoing currents. So IA, IB, IC, and ID can each be either a positive or negative number. So likewise, Kirchhoff voltage law, that is KVL, the algebraic sum of voltage around each loop. Loop is nothing but the closed current path, that is equal to 0. That is voltage drop equal to voltage rise, or voltage drop minus voltage rise equal to 0. Or this is the example of Kirchhoff voltage law. Here the Vs is voltage source, R1 is resistance 1, R2 is resistance 2, R3 is resistance 3. Here R1 or R2, R1 is connected in a series manner of the circuit, and R2 and R3 both two resistors are connected in parallel manner. Here Vs is nothing but the source voltage, likewise VO equal to output voltage. Here we take it as a point number A, point number B, point number C, and then a closed circle. Assign the current variables and directions. Likewise, use Ohm's law to assign the voltage and polarities consistents with passive devices. Current enter at the plus direction, that is A point, that is I1, that is divided into I2, and then it reaches the negative value. So this loop, take this loop as a first example. I am going to assign a value based on Ohm's law, that is I1 is V1 is nothing but I1 R1, and then V2 is nothing but I2 R2. So here, starting at node A, add the first dropping voltage, that is I1 plus R2, adding the second drop value, that is I2 plus R2. According to Kirchhoff voltage law, the subtract the voltage rise from C to A through Vs equal to I1 R1 plus I2 R2 minus Vs, that is voltage source, equal to 0. Or notice that the sign of each term matches the polarity encountered first. So this equation we can also express to I1 R1 uh, plus I2 R2 equal to Vs. The voltage source of the Vs always equal to sum of both I1 R2 R1 plus I2 R2. So this is the basic representation